This is question 5 from the first CSAT sample paper. So in this question we're asked to find an expression for the overlap between two intervals, and they're given very generally. It's just a1 to a2 and b1 to b2 using the functions min and max, but as a single expression. So we're not splitting it into cases and saying what the expression is in each case. We're going to find a single expression. So if you want to have a go at this question yourself, pause the video now. Okay, so I think here it's easiest to try and deal with a simple case first and then think about everything that could go wrong and what changes you need to make. So what do we immediately think of when we think about the overlap between two intervals? Well, we imagine them looking something like this. We've got, say, a1 to a2 here, and then we've got, say, b1 to b2 here, and then what's the overlap going to be? The overlap in this case is going to be, well, we're going from here to here, so it's from b1 to a2, and the length of that is going to be a2 minus b1. So that's our first guess. But there's a bunch of things that could go wrong. Well, first we note that we haven't used min and max. But one thing that could happen is this interval could be over to the right instead. So let's say b2 could be here and b1 could be here, in which case it would be b2 minus a1. So that's something else we could get, b2 minus a1, if the interval was, say, here instead. And something else that could happen is this interval could be shorter so that it's completely contained in this one, or vice versa. So let's actually think about that case first, and then I'll come back to this one where it's on the left. So suppose instead b2 was here. Suppose b2's here, then what's the overlap? Then the overlap is going to be the whole of this interval, because this interval is just contained in this one. So in that case it would just be b2 minus b1 is the length of the overlap. So using min and max, how can I, let's ignore this one because that's where it's on the left. Just think about what I said before was a2 minus b1, in this case where the second interval is quite long. If this interval is contained in this one, it's going to be b2 minus b1. How can I sort of combine those two cases in a single expression using min and max? Well, the point is, whichever of a2 and b2 is further to the left, that's the one I'm going to use. So if b2's further to the left than a2, then the overlap stops here at b2. But if b2's further to the right, then the overlap stops at a2 instead. So that means what I want to use is the minimum of a2 and b2 is going to be my upper limit. And that suggests I should be doing something else with this as well. Bear in mind I've only used min, I haven't used max. And then what we see there is, well, I've drawn a1 over here, but a1 could have been, say, here instead. And in that case, this interval a1 to a2 would be contained within b1 to b2. Let's go back to this case where b1 to b2 is quite long. And then what would the overlap be? It would just be a2 minus a1. So we can see what we're using isn't always b1, it's going to be whichever of a1 and b1 is further to the right. If a1 is further to the right, then the overlap's just this. But if b1 was, say, here instead, then we'd be doing this, we'd be using b1. So that means what we're using is the maximum of a1 and b1, and that's what we're taking away. And this looks like a promising answer. We're not actually done yet. Let's see why not. Well, one thing we might worry about is I drew b1 to b2 over here. It could have been on the right hand side instead, so it could have been like here. Actually, now I've written this, it doesn't matter that it's over to the left. And that's because min and max are symmetric in the two variables. So if I swap the a's and the b's around, it doesn't change the answer. If you wanted to, you could go through all the different cases with this on the left instead of on the right, but you can see it doesn't make a difference. So that's not a problem. What is a problem? Well, the problem can come if there isn't an overlap at all. So what could happen is we could have A1 to A2 here, and then B1 to B2 here, and they don't overlap. And then what answer does this give in that case? It gives me the min of A2 and B2, so that's over here, minus the max of A1 and B1, so that's here, and that's going to give us this minus this, so that's going to be a negative number because this is actually smaller than B1. But the overlap can't be negative. In this case, the overlap should be 0. So we want to make sure that our overlap can't go any smaller than 0, and there's a trick to doing that. Well, basically what do we want to say? We want to say if this is positive, we want to take this. So if this is bigger than 0, we want this. If this is smaller than 0, we take 0. So that means we just want the maximum out of this and 0. So what we actually want our answer to be is the maximum of 0 and then this expression, which I'll just put in brackets to make it a bit clearer. Like this. And now this is going to be our final answer, because for the cases where they overlap, we already saw this works. Where they don't overlap, we've now made sure that the smallest it can go is 0, it can't go negative.